artificial intelligence will completely transform our world. But what is AI? Why will it affect you? And how can you and your business survive and thrive through the AI revolution? Welcome to AI and You. Here is your host, author, speaker, and futurist, Peter Scott.
Hello, and welcome to episode 285. And returning to the show after a year, today is Craig Kaplan, who has the website Superintelligence.com, which gives you an idea of the thought space he inhabits. Craig is CEO and founder of IQ Company, focused on AGI and ASI, artificial superintelligence. He also founded and ran Predict Wall Street, a financial services firm which used AI to power a top hedge fund. He has a PhD from Carnegie Mellon University, where he worked with Nobel-Prize-winner and AI pioneer Herb A. We had a fascinating talk a year ago about so many things, including and especially collective intelligence, which will show up again in this interview. As much as we'll be talking about the possibility of AI becoming superintelligent and independent, which are seen as existential risks by a large community, I've got to say that Craig is possibly the most optimistic person I have met in this space, and his optimism comes through in this interview. We're going to talk about Craig's concept of democratic AI. Small d there, we're not talking about Democrats versus Republicans. That should definitely be another show. But kind of a hive mind of AIs that combine to work together safely. And how do they talk to each other? What are they made up of? And we'll also talk about systems for solving ethical problems. So let's get into the interview. Craig Kaplan, welcome back to AI and You. Last time you were on the show just over a year ago, we talked about you writing an AI to predict Wall Street and your collaboration with the renowned AI pioneer Herb A, and a lot of detailed cognitive modeling stuff around the idea of collective intelligence. Really worth our listeners going back to episodes 222 and 223, not in any way dated. And so a year has passed under the bridge since then, a lifetime in AI these days. How has your approach evolved since then?
Peter, great to be with you again. I think AI, as your listeners probably know, is moving. 1 month of development in AI is like 2 or 3 years of most normal technologies in my experience. So a lot has happened. I think the biggest thing that happened, and we can talk about this if you like, is just a couple of weeks ago at the GTC conference, which is NVIDIA's largest developer conference in Washington, D.C., the CEO of NVIDIA, Jensen Huang, said for the first time publicly that I've heard him say it, AI is not a tool. He said, AI is not a tool. AI is, in fact, workers that can use tools. And the context of this was, he, of course, is a business person and was talking about the tools market, IT tools, software, and so forth is $1 trillion market. But if you have workers that can use these tools, that's potentially 10 times bigger. So that was sort of his slant on it. But I've been following this very closely, this idea of when is that going to hit mainstream, where people cross over from saying AI is just another technology, another tool that people can use, to recognizing and actually publicly acknowledging that no, maybe it started as a tool, but it's not going to stay a tool. In fact, it's becoming an intelligent entity. So to me, this was a watershed moment and actually is potentially a turning point. I don't want to overstate it, but for humanity, because humanity has never had a situation where we've created intelligent entities. We've created tools all the way back to the Stone Age. We're used to dealing with tools, but this is the first time. It's a whole new category, workers that are getting very close to human level intelligence, and in a few years will easily surpass us. And it's a big thing that someone like Jensen is now saying this publicly, given the clout and the weight and all the deals that he's doing.
Well, thank you. And I think that what you just described there will have a lot more weight with the audience if we put it in the context of the evolution of the work that you've been doing. Last time that was collective intelligence, and well, I'll let you describe that, but you're now talking about democratic AI. And I think that if we talk about that we'll see an intersection with what Jensen was talking about that will be really key. So can you talk about collective and then democratic AI? And we'll be getting into superintelligence later, but let's pace ourselves.
Sure. So it's probably helpful. I always like to zoom out and see the big picture. So I start, as you may know, 1956, when the field was named at the Dartmouth Conference. And what's interesting to me about that date is not only was the field of AI named, there were 11 scientists that came together to name the field, but also 2 of those scientists presented for the very first time a working AI program that was actually creative. It came up with a proof. It was supposed to just find proofs that were already in a textbook, and it came up with a new proof that the authors, who were distinguished logicians, including Bertrand Russell, had not thought of.
And we're talking mathematics proof here, right? Pure math.
That's right. The program was called The Logic Theorist, and it was proving mathematical proofs from the book Principia Mathematica. And so you can argue that there were glimmers that AI is not going to be just a tool all the way back in 1956, 69 years ago, 70 years ago. If you fast forward, sort of the evolution has been first narrow AI systems, then machine learning, where you can sort of shovel a whole bunch of data and lots of computational power, and the system can sort of self-organize and learn. And that's kind of the basis that started really in the 80s. And as computing power got faster and faster, finally, November 30th, I think 2022 was the release of ChatGPT. That's when it sort of burst upon everyone's consciousness that this machine learning approach could really produce AI that seems intelligent or at least useful. And then if I sort of sketch, I kind of have in my mind an evolutionary time frame, and I'm just watching the boxes get checked, right? Because I studied with Herb Simon, so of course I was exposed to 1956. To me, the idea that AI would not be a tool is not new. It's like I was brought up with that from the 80s on. But I've been watching as sort of the consciousness of people in the field is evolving. So you get these narrow AI systems, then you get large language models that are more general. People are arguing about whether we've reached artificial general intelligence, which can be defined as sort of AI that can perform any cognitive task as well as the average human. Some people say we're there. Some people say, I think Sundar Pichai at Google says, another few years, but we're getting very close. From there, we go to superintelligence, and then in my view, ultimately planetary intelligence, which we could talk about later. In terms of democratic AI and where that fits in, there is a big issue in this evolution. Once you cross over from tool to autonomous agent and worker, as Jensen Huang said, intelligent entity, now you have to start worrying a little bit, because autonomy means that these AI agents potentially are no longer under your control. Now, right now they are, of course, but there have been lots of examples. The Air Force has done thought experiments where they put the AI in charge and it decided in order to score more points, it should kill its operator, right? I mean, this was a couple of years ago. And there's all kinds of problems when the AI is given autonomy. It doesn't have to even be malevolent. It can just be trying to do what it thinks you want it to do. And it comes up with a creative solution that, oops, killed the wrong folks, So there's a lot of safety issues. And this led me to the notion of how do we make AI safer? And I think there's a couple important points, but the key one that relates to democratic AI is that it's possible to design advanced AI in a different way that's much safer than what people are currently doing. And that's the notion of democratic AI. Instead of having one giant large language model, which is what everyone's doing, you build GPT-4, then GPT-5, then GPT-10, and each time you simply add more data and more GPUs and use the scaling laws to create a more powerful AI. Well, the problem is GPT-4 was a black box. You couldn't predict what it would do, and it was difficult to control, and you tried to guardrail it and after the fact don't tell people how to make bioweapons and so forth. Imagine if you take that same approach and you don't change anything, and now you've got GPT-10 that's way smarter than any of us, and it's still a black box. That would not be good. So a different approach is to say, let's have a community, a democratic community of AI agents. Let's acknowledge that these are intelligent entities. If you want, I'm pretty sure that everyone's moving there. There's still some holdouts. No, it's still a tool. it's an intelligent entity. But even if you want to think of it as a tool, that's okay. You're going to have a lot of these AI agents. And when they work together in a community, you solve a very important problem, which is you don't have to look inside the black box of each AI. You just look at what each AI does, just like in a society, in a democratic society. Peter, I don't know what's in your head. I don't know what you're thinking, and you don't know what I'm thinking, but I can see your actions. I can see, oh, you took this action, and you can see the actions that I took, what I said and what I did. And we have rules governing the society in a democracy that enables millions of humans to interact, for the most part, relatively peacefully. There's definitely squabbles, and we have lots of troubles with our democracy, but we haven't killed everybody yet. And so with these AIs, it's the same general idea. If you have millions of them working together on a network, each one can be a black box, but you can see the actions that each takes, and there can be rules that govern their interaction. And just as in a democracy, you can have checks and balances, different groups of people serving as checks on the behavior of other people. You can do the same thing in a democratic AI approach. And that scales really well because remember, right now, humans are still smarter than the AIs, but in a few years, as computational power increases, there will come a time when human thinking cannot keep up with what they're doing. But if you have the AIs themselves checking each other, then that's a scalable way to solve that problem. So I'll pause there and see where we want to go here.
So really fascinating. And I'm connecting a lot with what you said the last time you were on the show, and we're not going to recapitulate that. So I would really encourage everyone to go back again, episodes 222, 223, to listen what we said about collective intelligence then. And it sounds like that democratic AI is kind of like an application of that. You break AI down into lots of little chunks where you define the boundaries and interfaces between them. And it seems as though you're relying on the wisdom of crowds to produce positive effects. Would you characterize it like that?
To some degree, the wisdom of crowds, what I like about that idea and collective intelligence in general is that it highlights the fact that many minds can be more powerful and more intelligent than a single mind. And I think all of us know that. No matter how smart any one individual is, if you have an entire company or an entire group focusing lots of brain power on solving a problem, typically that group is going to come up with answers that are better than the individual can do on their own. And so that definitely applies to this democratic AI approach. The part that's a little bit different is sometimes people, well, it just depends on how you define wisdom of crowds, but sometimes people think of it's the masses. You can have wisdom of crowds and madness of crowds, right? People can panic. People can come up with bad ideas because they all panic at the same time, or they're all subject to the same sort of biases. And I think with democratic AI, it's very important that each AI on that network is personalized and carries the expertise and the value system, the ethics of individual humans. So Peter, in your case, already you can see it's becoming easier and easier to personalize AIs. I'd be surprised if you haven't been using them and maybe personalizing some GPTs or something with your writings to have it, generate stuff that sounds more like you. I'm doing that. Most of the people that I run into are doing some version of this. So already we're beginning to personalize these AIs. Imagine a world where just fast forward a couple years and that gets even better. The AI agents know everything you've ever written and every podcast you've ever done. They've analyzed your thinking patterns. They know your expertise, but very, very importantly, they also know your value system. They know what you feel is right and what you feel is wrong. They know how you feel about social issues and ethical issues. And so in a way, your ethics are embodied in this AI agent that has been personalized to you. And the same for me, and then multiply this across millions of people. So now these agents, it's not just wisdom of crowds where they're, in the classical sense, where they're bringing their expertise and maybe by combining it, you get an edge. You're actually representing lots of people's values. So you have a representative view, not of the ethics of 20 people in Silicon Valley at OpenAI who decided what was right and what was wrong for their large language model, but rather millions of people that are hopefully representative of all of society. And these AI agents, if the democratic system is properly architect it, they're going to have conflict. Your values may not be the same as mine. If we go to a different culture, I'm sure the values will be radically different. And yet, humans are able to negotiate that. How do we do that? There's a lot of techniques for conflict resolution. There's voting. There's running simulations, ethical simulations, and seeing what the output would be, and then feeding that back to humans and say, is this really what you want? That sort of thing. So the democratic AI system can have all those capabilities, and we can go into that more. But just a few of them are the ability to vote, the ability to access a lot of conflict resolution mechanisms that humans use, and really think of them not as tools. That's why we started with that. It's not a tool anymore. Even Jensen says it's not a tool. These are intelligent entities now. And at some point, we're going to need to respect them as such. And hopefully, they're intelligent entities that were personalized by us, at least in the beginning, and therefore carry our value system. And when they interact with each other, we can kind of have a democratic process working. It may work much faster than humans would do it because their computation is so much faster. But by distributing across millions of them, hopefully the power is not centralized and we end up with a good outcome.
You've put a lot on the table here, and I want to pause this very carefully because it would be all too easy to boil the ocean here or try to and not do one topic, in particular, the justice it needs. And you started this conversation with the viewpoint of safety, that we're joining together these AIs in this community, not just because they can be more intelligent that way, but because they can be safer. And so that sounds like a government. That sounds like an assembly of people. That sounds like, as you say, a democracy. And that depends upon, well, I think a couple of things. I'll put them both out, and I think each of them deserves some drilling into in quite detail. One is that when we look at assemblages of people, the interfaces between them are necessarily constrained to language, like we're talking right now. But that interface between us of exchanging words and expressions is a lot more constrained than hooking together two brains. And the reason that I'm drawing this distinction is because I think that you would get pushback against your idea from the people that are pushing the big models, you know, your OpenAI, Google, and so forth, saying we don't need a whole bunch of little ones. We need a big one, specifically our big one, to do all those things because it can be trained massively. And so I think one distinction to drill in on is the fact that those interfaces are necessarily constrained because implicit in your description of this assemblage of AIs is the idea that the interfaces between them are understandable to human beings, which is a big factor compared to the fact that we don't understand what's going on in any large AI at the moment. The other question I have is a much smaller question, but equally important, is to what extent is it necessary that these many different AIs or many smaller AIs be heterogeneous as opposed to homogeneous, like all from the same vendor, all the same model, that sort of thing. You can take these in whichever order you want. Happy to spend as long as you want on one and remind you of the other one when you are ready.
Okay, great. There's a few things to unpack there. So first, a quick comment on sort of the resistance. I am very sensitive to this idea that there's a lot of very powerful forces at work here. So we live in a capitalist society. You have Google competing with OpenAI. You have the US competing with China. So there's incredible, very, very intense competitive pressures and huge amounts of money flowing. And I think this is the reason why certain efforts for AI safety, such as pausing all AI development or halting development, have just essentially been ignored. People are willing to sign a statement saying that there's existential risk, but that's it. And they're willing to give lip service to, well, we can regulate it like any other technology, which, by the way, no longer really makes sense, right? If Jensen says it's not a tool, it's a worker, it's not like an airplane where you can have rules for the airplane or like a chainsaw where you put a guardrail on a chainsaw. No, it's an intelligent entity, much different in terms of regulation. So there's very powerful forces at work. And the large language models that are being developed by Google and OpenAI, you mentioned, well, maybe there's some resistance. But actually, this approach is inclusive. So if you're Google and you make a really powerful large language model, that's fine. You can have personalized agents based on that large language model that can participate in the democracy. So the community is always going to be smarter than the smartest agent, as long as you're willing to allow those smartest agents to also participate in the community. So you'll have the intelligence of that really the smartest agent on the block, plus all the other agents. And that combination is going to be better than that smartest agent on its own. So that's one point.
Well, just to open up a small can of worms there, are you envisaging some kind of protocol or framework for today's AI models, your ChatGPT, your Gemini, your Grok, to talk to each other to form this large assemblage, or were you envisaging that assembly being composed of something else?
Yes. Okay, so great. And this is a good segue into part of your other question. Is there this heterogeneous participation, and then do you have a common interface? And is it important that it's human understandable? And how are we going to do this? And I think you're right to mention that, because the devil's in the details, and that's the key detail, is how do these large language models interact with each other? My view on this is slightly different than maybe what a pure computer scientist would say. Most of the AI researchers and computer scientists are coming at it from computer science, and they think in terms of zeros and ones, and how do I get my model to solve a problem? And let me use, minimax search and the various AI techniques that have been developed over 70 years.
Yeah, and those people are thinking of the Model Context Protocol right now.
That's right, MCP, Model Context Protocol, and how, to their credit and to the field's credit, I think we're seeing already that there are some emerging protocols that many different agents, doesn't matter which vendor created the large language model. Here's a common protocol to enable them to use tools. And I think they're also coming up with inter-agent communication protocols. And I think most people's goal is to have those work with AI models from more than one vendor or more than one technology company. So that's all good. But that leaves out the human. And see, my training was originally in cognitive science. So my view of intelligent systems is not just computer science and AI systems. I look at humans as intelligent systems also. We are also information processors, and humans must be included. So whatever MCP or protocol is developed for these AIs, it has to work with humans, because in my view of this democratic AI, it is not just AIs by themselves. At least, certainly for as long as possible, it should not be AI by themselves. We should have humans involved. And that means we have to have a protocol that humans can understand and that works with humans.
So, and if you're talking about like democracies and that leads to governance here, then and it needs to work with humans, then that makes me think Robert's Rules of Order.
Well, you could go there, but we don't have to start as restrictive as that. Let's start more where Herbert Simon and Alan Newell started, who were the two guys that came up with the logic theorist way back in 1956. In 1972, they had another big breakthrough. And of course, I'm biased because I studied with these men. And so it took me a lot of years of investment to finally understand this. It's like a thick book, about 2.5 inches thick, called Human Problem Solving. That was 1972. And in that book, they basically outlined a protocol. They didn't think of it as such at the time. They were coming up with a universal theory of problem solving. And that theory could handle any type of problem solving that humans do. And most cognitive tasks actually can be framed as problem solving. You have a goal, and there's a place where you're starting, there's a place you're trying to get to, and there's some actions you can take that sort of reduce the distance between where you are and where you want to go.
Well, you just described the field of computer science.
Well, computer science also picked this up, and there's a lot of synergy and interaction between the theory of human problem solving and a lot of the AI development that happened kind of in parallel, where if you were developing an AI program and you were having tree-based search and means-ends analysis and a lot of the computer science heuristics and techniques for solving problems, yes, they're the same. So it turns out, whether it seems obvious or not, to me, it's a stroke of genius that you can use the same structure for problem solving, which can handle almost all cognitive tasks that are complex. Perception, no. Pattern recognition, no. Those are different. But when you get into sequential multi-step reasoning, so think of reasoning, all the emphasis on AI reasoning systems, all of that kind of work can be described by this theory of human problem solving, which also works for AI systems. Okay, great. So now we have, at least theoretically, a framework that ticks a lot of the boxes that you mentioned in your question. It's understandable by humans because you can see this is the goal, this is the sub-goal, this is the next step that I took. I'm not saying humans necessarily want to go through all the work to trace all that, but if it's recorded automatically in the system as part of the architecture, theoretically, you could audit it. And if there was ever a problem, you could say, oh, here's where the problem was. When the group of agents set this goal, that's where they went wrong. That goal was unethical. In fact, as a slight tangent to explain or illustrate how safety can be built into such a protocol, suppose you had a rule that every time a goal was set by the system, a goal or a sub-goal. So let's say the AI system is saying, we have this problem, we have to get Craig and his pet dog from California to Paris. And so that's the problem. And so it comes up with travel arrangements and all that. And it asks, how big is the dog? And the AIs sort of just logically solve it. And they say, well, we can stick the dog in the overhead bin because it will fit. And that will sort of, reduce the cost of the flight. And you don't have to buy. And the human can step in and say, no, that violates when you set that goal of how do we get the dog, stick them in the bin, how do we do that? It's like, oops, no, you're not allowed to stick small animals in the bin. That's inhumane. So you can have built into the system sort of a way of scanning the goals as they're being set and saying, is this an ethical goal? Does this pass certain ethical tests? And if it does, then the system can proceed. And every step in the process is auditable and transparent. And it works with humans and it works with AIs. The AIs will, of course, have to translate what they're doing in zeros and ones into this underlying architecture. But that's not a problem for them, right? They're good at doing that sort of thing.
It does make me wonder how scalable that is, because ethics is situation dependent and it's not usually as binary as that choice. Like, I'm not going to say that there are situations where putting a dog in the overhead bin would work. I can't think of any at the moment. But in most situations, something that we would think of as being a binary choice isn't. There is some context in which the thing we say no to should be something we have to say yes to. And that's then fine, but it could multiply very rapidly if you're trying to apply that fuzzy logic over the entirety of human value system.
So it can't be static. This has to be dynamic and constantly evolving and adapting. There are cultures, I am not in favor of this at all, I want to be very clear, that eat dogs, consider them food. And there are other cultures that view them as valued members of the family. And so there are big cultural differences. And you're absolutely right. One set of ethics is not going to fit all. And ethics don't even remain constant over time. You can go back 20 years and see that there are things that nobody batted an eye that was going on. And today we say, that's horrible. How could that have done? All you have to do is look at some old movies from the 50s or something, and you see plenty of behavior that would be completely sort of out of bounds today. So ethics are constantly changing over time. They're changing via culture. They're changing person to person. And that's okay, because figuring out what the ethical rules are is just another problem, right? And then you can get people working on that. So the beauty of a problem-solving system is that almost anything you can think of, whether it's ethics or coming up with the rules of order or modifying the rules of order or determining who's allowed to do what on the system, all of those things can be framed as problems. And at the most basic level, the same architecture can handle them. They become sub-problems. We need to refine the set of ethics here.
That's the end of the first half of the interview. We split most interviews up to keep these episodes under the average commute time, and it also helps us maintain a regular cadence. In today's news ripped from the headlines about AI, OpenAI has launched Aardvark, an AI agent powered by GPT-5, now in private beta. Aardvark is designed to function like a human security researcher. It reviews entire code repositories, models threats, inspects commits, and assesses newly introduced code. When it spots a potential vulnerability, it runs exploit tests in a sandbox environment to verify whether it can be triggered. It also proposes patches via integration with OpenAI's Codex generation agent, submitting pull requests for developer review. In benchmark tests on curated repositories, it achieved a detection rate of 92%. The agent has already been used on open-source projects and discovered multiple critical vulnerabilities, some of which received official CVE designations. This initiative signals a shift towards continuous integrated security within development workflows rather than post-hoc scanning. For now, Aardvark's availability is limited to organizations on GitHub Cloud under private beta terms. One of our all-too infrequent public service announcements here. Please, if you like this show, tell other people that it doesn't get much easier than hitting the like button. But if you go the extra mile and write a review, preferably a great one, lukewarm reviews don't help a heck of a lot, then the algorithm will see to it that a whole lot more people who think like you do will find out about the show. And doesn't that sound great to be around more people who think like you do? Next week, we'll conclude the interview with Craig, when we'll talk about rights of AIs, safe superintelligence, where AI gets its values, and how model vendors might be incentivized to put their products into the collective AI intelligence. That's next week on AI and You. Until then, remember, no matter how much computers learn how to do, it's how we come together as humans that matters.
That's all for this episode of AI and You. Please leave a rating and comment and share with your friends. Get the book Artificial Intelligence and You and see more videos and articles at aiandyou.net. That's aiandyou.net, where you can also send us your questions. Thank you for listening.